Okay, powers and roots worksheet. I'll try to go through fairly quickly. When we have something that's in rectangular form, you always want to put it in polar form because the properties for powers and roots are a lot easier in polar form. So we need to first figure out where radical 3 for the real part and -1, what we know about that in polar form. So to find the radius, we have to take square root of 3 squared plus -1 squared, and I get 3 plus 1 is 4, square root of 4 is 2, so r is 2. So once you have r, you should be able to try to figure out theta. Theta, I can look at the cosine. The cosine is radical 3 over 2. The sine is -1/2, and so that happens at negative pi over 6. That the cosine is radical 3 over 2. The sine is the opposite over the hypotenuse. All right, so once you have that, you can write it in any form. Sometimes I think if you put it in exponential form, it makes the most sense. So my radius is 2. My angle is negative pi over 6. And so I want to take that number, it said, I want to take that complex number and raise it to the 7th power. Well, what do you do when you raise something to the 7th power? I have to take 2 to the 7th power. So 2 to the 5th is 32, 2 to the 6th is 64, so I believe that's 128, 2 to the 7th. And then when I have e to this power raised to another power, I multiply the exponents, I get -7 pi over 6i. And that's it, I'm done. It doesn't say I need to convert it to any other form, that's all I need to do. So I do the same thing with 1 plus I, so I have to figure out where is 1 plus I, 1 over, 1 up. So my radius is square root of 2, and I would probably think of that as 2 to the 1/2 power, because I'm going to have to raise it to the 95th, and it's harder to take the square root of 2 and raise it to the 95th. I think it's going to be easier to take 2 to the 1/2. They mean the same thing, but writing it in exponential sometimes when we're dealing with these powers is easier. All right, so my radius is 2 to the 1/2, and my theta, anytime you go over the same amount as you go up, your theta is a reference angle of pi over 4. So theta is pi over 4. So I want to take that number, which I'm going to write in exponential form, my radius and my theta, and I want to raise that number to the 95th power. It says I want to take that number and raise it to the 95th. So again, here I have 2 to the 1/2 raised to the 95th. I'm going to get 2 to the 95/2. And that's the square root of 2 to the 95th power, which is some really big number. And then my angle, I have a power here raised to a power, so if I multiply those, I get 95 pi over 4. And I can leave it like that. Now obviously 95 pi over 4 also goes around the circle a whole bunch of times, and we could figure out what coterminal angle is a little smaller than that, but we can leave it as 95 pi over 4. That's fine. Okay, that's all you need to do for raising to powers. Okay, so for roots, remember the first step you always want to do is you want to figure out where does this end up? Where is z to the 4th? So this says I'm going to have a real part of -16 and an imaginary part of 0. So that tells me my radius is 16, my theta is pi. So that's what z to the 4th is. Z to the 4th has a radius of 16 and an angle of pi. Okay, so to find my roots, I always label them z sub 0, z sub 1, z sub 2, z sub 3. I have to have 4 answers if I'm finding the 4th root. And so all I need to do is take my radius, which is 16. I need to take the 4th root of that. What number times itself 4 times gives me 16? 2. For my angles, I find the first angle first. It says, okay, my original z to the 4th had an angle, a theta of pi. So if I'm going to take the 4th root of that, I have to divide that by pi. So I get pi over 4. That's how you get the first angle. You just take your theta that you have of your original number. If you're taking the 4th root of that, you divide it by 4. That's my first answer. Now, then you just have to decide, okay, what do I need to keep adding to get around and you can kind of think about the graph of it. If there's pi over 4, 2 units out, I want to have 4 equally spaced answers. So what am I going to add each time? I'm going to add 2 pi divided by 4. Because it's all the way around the circle, it's 2 pi, but I want to divide that into fourths. So I'm going to really add 2 pi over 4, so this one's going to become 3 pi over 4i, which should be here. Then it's going to be 5 pi over 4i, which is here. And then it's going to be 7 pi over 4i, which is here. So again, then they should be the same distance. These probably aren't, but these should all be the same distance as well. Okay, so there's my 4 answers. All right, let me see if I can do another one. Z to the 5th is 1. So again, it's 1 plus no i's. So I go 1 over 0 up. So my r value can be 1. My theta can be either 0 or 2 pi. It doesn't matter which one you use. It could be 6 pi for that matter. But as long as you name it so that it's over here. All right, so then if that's what z to the 5th is, 1 e to the 0 pi I, or 1 to the 0 I if you don't want to put pi there. All right, that's z to the 5th. So I'm going to take the 5th root, which means I have to have 5 answers. Z sub 0, z sub 1, z sub 2, z sub 3, z sub 4. All right, to get the first answer, I need to take the 5th root of my radius. Well, if the radius is 1 and I take the 5th root of it, what number times itself 5 times gives me 1? 1. So all of these have a radius of 1. If it has a radius of 1, you technically don't have to write the 1 there. I do just to remind myself of that. And then I'm going to take my original angle, which is 0, or 0 pi, if you want to keep the pi in there. If I have 0, and I divide that by n, so if I divide it by 5, I still have 0. So you either can say e to the 0 I, or you can say e to the 0 pi I. And what am I going to add? I'm going to add 2 pi divided by 5, because I need to have 5 equally spaced numbers. So if I'm at 0 and I add 2 pi over 5, that's 2 pi over 5i. If I add 2 more, it's 4 pi over 5i, e to the 6 pi over 5i, and e to the 8 pi over 5i. And if I got to 10 pi over 5i would be back to here. So if you had an answer, if you started with 2 pi, you might have actually got these answers, but then instead of this answer, you would have gotten 1e to the 2 pi I. They mean the same thing. They both end up at over here. So when you go to graph it, just make sure you might have named it differently, but we're going to have one here either at 2 pi, if you called it 2 pi, or you called it 0. You're going to have one at 2/5 pi. You're going to have one at 4/5 pi. You're going to have one at 6/5 pi. You're going to have one at 8/5, which this would be 7.5, so it's a little bit more than half. And you're going to have one over here. So, they should look equally spaced. Mine probably don't look the best, but and they don't look symmetric, but they should be equally spaced, 2/5 of a pi apart. All right, let me do this last one. I have -1, 1. So this is square root of 2, or 2 to the 1/2, if you want to use that. The angle, because again, the reference angle is pi over 4. Theta is 3 pi over 4. And radius is square root of 2. So if that's what z squared is, that's z squared. I want to take the square root of that. So I'm going to have a z sub 0 and a z sub 1. So if I want to take z sub 0, I want to take this radius that I had, and I want to raise it to the 1/2. I want to take the square root of that. So if I take 2 to the 1/2 and raise it to the 1/2 power, I get 2 to the 1/4. Or if you want to write it as the 4th root of 2, they mean the same thing, whichever way you want to write that. And then my angle, well, here's my original theta, 3 pi over 4. I'm taking the square root, so I have to divide that by 2, which means I'm going to get 3 pi over 8. What am I adding each time? I'm adding 2 pi over 2. So I'm really just adding pi is what I need to add. So if I'm at 3 pi over 8, if I add pi, which is 8 pi over 8, I get 11 pi over 8i. So there's my 2 answers. So when I go to graph that, 3 pi over 8 would be here, 11 pi over 8 would just be opposite that, because I added pi to get there. Okay, so that's the front page. Again, it's just mainly the skill is, can you find r and theta, given your number? And then whatever root you're taking, can you find the first angle by taking theta divided by 2, and then taking the that root of your radius, and then what do you add each time to get to all the other angles that you need. All right, that's page 1.